The big question that we need to address over the next 2 weeks is how is the real world represented in a GIS? GIS software uses two logical data models to represent real world features: the vector data model, which are points, lines, or polygons, and the raster data model, which is a grid made up of cells or pixels, also known as picture elements. In a vector data model, points, lines, and polygons represent real-world features. Points such as trees or fire hydrants or mailboxes, for example, can all be represented on the map with points. Lines, such as the pathway of a street or a train passage or streams, can be represented on the map. And polygons, such as the boundaries of lakes, also can be placed on the map in this vector format. In a raster data model, the landscape is represented by an electronic image that's composed of a rectangular array of square cells called pixels, with a number in each cell representing the solid color fill or brightness level of that cell. When used together, vectors and rasters can create a dynamic GIS. But vector and raster data models aren't the only models that can display spatial information in a GIS. Other data models such as triangular irregular networks or TINs, objects, and point clouds are also used, and we'll explore these as well. Now, after we explore data models, the next question is, how do we get data? For both the acquisition of raster and vector data, there are primary and secondary sources. For example, with raster data, a primary source would be digitally remote sensed imagery, and a secondary source would be scanned maps. For a vector data model, GPS measurements would be a primary, and topographic surveys might be a secondary. In the age of big data, and with the capacity of computers to hold a tremendous amount of information, GIS is sort of in a revolutionary period. We can collect data, display data, analyze data like we've never done before. So these next 2 weeks, we're going to explore what we can do with this spatial information and explore the true power of a GIS.